Okay, this is problem 11 from 2025 AMC 12A. The orthocenter of a triangle is the concurrent intersection of the three possibly extended altitudes. What is the sum of the coordinates of the orthocenter of the triangle whose vertices are, and they give us these three vertices here. So we want to find, well, they give us answer choices and we just want to find the coordinates of the orthocenter. So to do that, let's first just draw a diagram of what this triangle even looks like. So what I'm going to do is something maybe a little different. This is not going to be the normal x-axis. This is going to be the line y equals 27, or that's not the 2. Y equals 27, and this is just going to be the normal y-axis. And the reason I'm doing this is because this is basically just a normal triangle that's maybe a little bit low, but it's translated all the way up to y equals 27, so this just makes it a lot easier to draw. So for example, 2, 31, somewhere around here, this is going to be A. Then 8, 27, probably be on this, it's going to be on this line, and it's going to be maybe here. And then 18, 27 is going to be around here. And this isn't exact, this is just to get a visual of what this triangle looks like. So this is what the triangle looks like, and we have to keep in mind that this is the line y equals 27, this is not the actual x-axis. And so what we can see is that we want to find the altitudes. Well, we can find one altitude really easily. So let's say we extend this line, and this line is technically going to be on here, so maybe I should use a different color. But let's try to do this, the altitude to this side. So we can extend this side, and the altitude is the point from, or is it the line that's from this point that's going to be at a 90-degree angle to this side. So that line is going to look something like this, which is going to be 90 at a 90-degree angle. And so the formula of this line, which is the altitude, is going to be x equals 2, since that's what the x value is right there. And so that's one of the altitudes. And we know that in a triangle, then all the altitudes intersect at one point. So all three altitudes intersect at the same one point. So for us, we don't actually have to figure out all three altitudes. We just only have to figure out two altitudes. And we already know one of them is this line right here. So let's find the line for the other altitude. And it really doesn't matter which one you pick, but I'm going to pick this one. So let's say we're going to start from point C and extend this line. Line AB is going to get extended here. Point C is going to extend here. It's going to be this altitude. And we want to find out basically what is this line? What's the equation of that? So to do that, I'm first going to figure out what is the equation of line AB. And so line AB, if we just do this, we know that we have the coordinates for A, we have the coordinates for B, so we can just find out it's going to be y2 minus y1, x2 x minus x1. So it's going to be 4, which is the change in x. It's going to decrease 4, and it's going over 6. So it's negative 4 over 6, so the slope is negative 2/3, so we get y equals minus 2/3 x plus b. We have to plug in one of our points here, and I'm just going to plug in 31. 31 equals negative 2/3 times 2 plus b. It's supposed to be a times here. So 31 equals negative 4/3 plus b. So b has to equal 97 over 3. So we get the equation y equals minus 2/3 x plus 97 over 3. And I guess we didn't even have to figure out this 97.3 because we were only actually figuring out the equation of this line. And to do that, the only thing we care about is the slope here. And the slope for a perpendicular line is always going to be basically the negative reciprocal of the slope of the other line. So if two lines are perpendicular, their slopes are negative reciprocals of each other. So for this line right here, this is going to be the form y equals 3/2 x plus b for some b. And what's another point we could use? Point C. So we have the coordinates for C. We get 27 equals 3/2 times 18 plus b. And what works out really nicely is that 3/2 times 18 is 27, so b equals 0. So the equation of this line is just y equals 3/2 x. So now we have this equation, we have x equals 2 as our second equation, so now we just have to solve. So if x equals 2, we can just plug that in. We're going to get the point 2, 3. And so that's going to be the point where these things are just going to continue down here and intersect somewhere over here. That's what that 2, 3 is. So if we want to sum the coordinates of 2, 3, we get 2 plus 3 equals 5, which is our answer.